Okay, so in the previous episode, we created two variables called random dice index 1 and random dice index 2. In this episode, we're going to dive a little bit deeper into what variables and constants are and why they have data types associated with them. Okay, so open up your Xcode. Instead of going into creating a new Xcode project, what we're going to do today is we're going to use a playground. Now, this is something that Apple created to help people explore various ideas, essentially test out your code without having to have it associated with a design file or indeed an app. So open up your Xcode and we're going to click on Get Started with a Playground. And today's topic is going to be about variables, constants, and data types. So that's the name I'm gonna give it. Okay, so this is a brand new playground and I'm just going to maximize the screen here so that I can show you as much as I can. Now, the first thing that you notice here is this little blue line and a little play button. And this shows that currently our playground is in the manually run mode, which means that we have to press this button every time we want our line of code to run. Now, the beauty of playgrounds is that you can write some code, test it out, and see what happens before committing to a fully fledged app. Now, before we proceed, the first thing I'm going to do is I'm going to switch off this manual run mode because I want my code to be executed automatically every single time I type a new line. So to do that, I'm going to pull up this debug section down here and I'm going to click and hold on this play button. And now I get two options. I can get my playground to automatically run or manually run by pressing the play button. So we're going to switch it over to automatically run. And you can see now you have this little blue play button and we get rid of all of those smaller buttons, and now every single time I type a new line of code it will automatically run everything I type. And already in here you can see that it's preloaded with a single variable called string and its value is hello playground. We're just going to delete that because we're going to be creating our own. So remember, the first thing we type is the keyword var to show that we are creating a new variable, and then you give it a name. So for example, my new variable is going to be called my age. Now remember that in programming, when you're naming variables, when you're naming functions, it always follows camel case. So lower caps first and then every subsequent word is capitalized. This makes it easier to see and makes it less prone to errors. Okay, so a new variable called my age, and it is of type integer, and I'm going to set it to equal 32. What if I wanted to change this variable at a later stage? What if, 1 year has passed and my age is now 33? Well, add 1 year to it. So then I would only use the name of the variable. So notice that when I'm changing the value of the variable, I don't have to use the keyword var. That var is only for creating it. So now my age is equal to 33. And that was pretty easy. And if you look on the side of your playground here, now this is the beauty of playgrounds. You can essentially see your variable values at all times. Normally when we're working within our code projects, in order to see the values of these variables, we have to make it show up on a label, which will show up on the app, or indeed we use the print statement where we get it to print to the console. Now, by having playgrounds, essentially it just saves you this step of having to print it out, so you can see all the variables as and when they are created. So let's get rid of that print statement. Now, what if I wanted to make a different type of variable? Say I wanted to make a variable that held my name. Well, my name is something that doesn't really change very often, so there's no point using a var keyword to create a variable. Instead, what I can do is create a constant that doesn't ever change in value. So to create a constant, the keyword instead of var is let, and then I give it the name of my constant, which is going to be called my name, and it is of type string, of course, because name is going to be text, and then I'm going to set it equal to Angela. There we go. Now, if you try to change the value of a constant, for example, like we did with my age, my name now equals, I don't know, Jane. Xcode will complain and tell you that this is not allowed, and you can see the error reads, cannot assign to value my name is a let constant, and it points out exactly where this error is. So let's delete that line and make Xcode happy. So you can't change the value of constants. So essentially, you should consider variables and constants as containers or boxes that can hold values. And I'm going to show you in a bit more detail what I mean by this. If variables and constants are both containers or boxes that can hold values, then variables are essentially boxes that have an open lid. You can open it to put in a new value, such as a number in this case, and then you can take that value out and put in a different value if needed. But when you're dealing with constants, you're essentially dealing with a box that only allows you to put in a value once. Afterwards, you have to tape it up, seal it up, and you cannot change the value inside anymore. So variables and constants are used differently. Variables are there to keep track of the state of your app. So for example, which level is the user on, how many monsters have they killed, etc. But constants are there to hold pieces of data that never change. For example, your API keys or a URL. And constants also take up less memory space than variables. So let's head back over to our playgrounds and see what else we can do with variables and constants. Now, using variables and constants, it's quite easy to manipulate the values that are held inside. So for example, if I wanted to create a new constant called let my age in 10 years equal, then I would use my age and then I would just add 10 to it. So this is adding an integer to an integer, which of course has no problems. And my age in 10 years now equals 43, added from 33. I can do the same thing with strings, but of course you can't calculate strings. So what happens is that you can concatenate strings onto strings. So for example, let my full name equal my name plus a string that's a space plus my surname. And now you can see my full name now equals Angela Yu. So previously when we were printing out, so this is one way of doing it. Another way is using the escape backslash. Let me show you what I mean. So say if instead of writing let my full name equals my name plus my surname, what I can do is open up two quotation marks. Everything inside is going to be a string. Then I use the backslash and I use two parentheses, and inside I put in my variable, which is called my name. And then to that I add a space and I add my surname. Or if I had not just my name but my surname, then I can also just put in a space and then escape and then add my surname into here. And that would also give you the same result. My full name now equals Angela Yu. Now, of course, this isn't going to work when you mix up the data types. So what do I mean by that? If you try to add a string, so denoted by the quotation marks, called 10, to my age, then Xcode will complain and tell you that the binary operator plus cannot be applied to operands of type int and string. It's saying that you're trying to mix up a number with a string and it doesn't really know what to do with that. So that's not going to be allowed. Let's change that back to 10. So say if I wanted to print out my full details, so my age and my name, how would I do that? Well, you can use the backslash to escape your variables. Let me show you what I mean. Let's say we write let my details equal two quotation marks. So previously when we declared all our variables and constants, we've been explicitly telling Xcode what the data type will be. So for example, my age is going to hold integers or whole numbers. And my name is going to hold strings or text, essentially. Now, in this case, I'm actually letting Xcode infer the data type of my constant my details. Because I'm opening up the two quotation marks, it instantly knows that it's going to be a string that's going to go inside, and the type of my details is automatically assigned as string without me having to explicitly state what type it is. Now, the beauty of this is that you cut down on typing, but the inconvenience is that it's harder for you to tell what the type is without having it explicitly written out. So different people have different preferences. I tend to prefer not to explicitly state the data type just because it cuts down on time, but occasionally when working on collaborative work, and if the style guide of the project is that we explicitly state all our data types, then that's the way you go. So it really depends on choice, and you'll get a feel for what you prefer. Now here I'm going to create a string called my details, and it's going to hold both my name as well as my age. So how do we do that? Well, what you can do is you can use the / escape. So I'm going to write a / and I'm going to open up two parentheses, and inside these parentheses I'm going to put in my name, the variable, and then I'm going to have a comma and a space, and then I'm going to have another escaped variable, and in here I'm going to put in my age. Now, what this implicitly does is that it converts my age into a string and combines them together into this one line, which says Angela, age 33, and that becomes my details. So we briefly talked a bit about data types, but let's make it a bit more clear. When we're talking about data types, essentially you should think about it as one of these children's toys, the shape-fitting toy that you give 1-year-olds to play with. And it's pretty simple. You take the shape that fits the particular hole and then you put it in there. If you get the wrong hole, then of course it won't fit. And this is a really good analogy for variables and constants because they all have a fixed data type. So for example, if I had a variable that could only take strings as values, then if I try to put in a string, say ABC, then there's obviously no problem and it fits in easily. But instead, if I try to put in an integer, say 12, then it would give me an error and it won't let me do it. So each variable and each constant has either an implied data type based on the first value it was assigned, or it has an explicit data type which you tell it. So let's head back to our playgrounds and let me show you a few more data types. So we've already seen whole numbers, and those are of course of type int or integer, and they're essentially just numbers, can be negative or positive. Then we've seen strings as well, so that's usually for text, and it is of type string, so a string of characters strung together, such as ABC, and they're denoted by the quotation marks around them. Now what we haven't seen is booleans. So booleans are a data type that can only hold true or false, and the type is bool with a capital, and they can either be true or they can be false. Now another data type is the floating point number, or usually declared as a float. And these are your numbers with decimal places after them. But if in your programming you need numbers with decimal places to a high degree of accuracy, say if you're doing scientific calculations, then you will need to use instead something called a double. These are essentially 64-bit numbers, so they have a higher level of precision, and that allows you to have a number precision up to about 15 decimal places, whereas the float can only give you about 6 decimal places. So those are some of the most basic data types, and you'll be coming across some other data types during our programming lessons, and we'll mention them as and when we go along. But the most important parts to remember from this lesson is that variables and constants are essentially containers for data. With variables, you can change the value that's contained, whereas with constants, you can only assign it a value once. And with both variables as well as constants, they have a data type associated with them. And this can either be inferred from the value that you place inside the variable, or it can be explicitly typed, such as here when we declare that it is a string. So that was a brief intro to data types, variables and constants. In the Introduction to Swift Programming section, we're going to be diving a bit deeper into this, as well as other programming concepts. So I'll see you on the next lesson, and we're going to continue building our Dicey app.